Hey everyone! In this video, we are going to be doing a 2D kinematics problem where we are firing a projectile over a wall. Let's highlight the key information. Now we have a projectile and it's launched at 60 degrees with a velocity of 40 meters per second from a height of 5 meters. We have all the information that we need. Will it make it over a 35-meter tall wall that is 120 meters away? Well, this is a typical 2D kinematic projectile question, and we're going to go ahead and solve this. It's a two-part question. Part one, we're going to have to figure out first, when does the projectile, or when does the ball, or whatever it is that we're launching, when does it reach the wall? So in order to figure out when it reaches the wall, we're going to have to break that velocity into its x and y components because that's lateral, that's moving away from us, so that's the x component of our velocity. The x component of a velocity is always v cos theta. You keep practicing your vectors, x components are cos. So vx is equal to 40 cos 60. Vx is going to equal 20 meters per second. That means from the moment we launch this projectile, it is moving away from us at 20 meters per second. We can now use the equation v equals d over t to figure out when it reaches the wall. Our velocity is 20, the wall is 120 meters away, we're solving for time. We can clean this up by multiplying both sides by t and then dividing both sides by 20, which gives us a wonderfully predestined time of 6 seconds. That means from the moment this ball is launched, whoosh, or projectile, whatever it is we're throwing, it takes 6 seconds to reach the wall. End of part one. Time for part two. Now that we know that the ball or the projectile is going to reach the wall in 6 seconds, we need to determine the height of the projectile at that time. So at 6 seconds, how high is the projectile? If it's higher than the wall, we'll know that it went over the wall. If it's lower than that wall, which was 35 meters, we'll know that the projectile hit the wall. Because we're talking about height, we are again going to have to break our velocity into components. Height is determined on the y component of velocity. To get the y component of velocity, it's v sine theta. Sine always up and down, cos left and right. So the vy, the y component of our velocity, is 40 sine 60. We chug that out into the calculator and we get that our upwards velocity is 34.64 meters per second. If you want to solve the height of a projectile, it doesn't matter whether you're dropping a rock down a well, throwing a ball into the air, kicking something off of a cliff, you always use the equation d equals 1/2 at squared plus vit plus di. This is the gravity height equation, and it's what we're going to be using. And we know most of this. So d is equal to 1/2, we know gravity, that's negative 9.8. We know our time in this situation. We solved that in part one. It's 6. So we have a 6 squared plus our velocity initial. Because we're talking about height, we have to use our vertical velocity component. Put our time back in once more. And don't forget that in this question, you were given an initial height of 5 meters. So don't forget that plus 5 at the end. We have everything we need here. There's not a lot of algebra. This can go directly into a calculator, and we'll get that the distance, in this case our height, is 36.26 meters. 36.26 is in fact greater than 35 meters. Therefore, it goes over the wall. The projectile made it over the wall. If you had gotten a number below 35, it would have hit the wall. And some folks might ask, what if the ball or the projectile never even made it to the wall? Because we solved that 6 seconds, but it actually doesn't matter whether it made it to the wall or not. If the projectile hadn't even made it to the wall, when you filled in for distance, you would have gotten a negative number. And negative just means it would have hit the ground before it got to the wall. You still would have gotten a number less than 35, which still meant that it didn't get over the wall. I hope that this was helpful. If you have any questions, please feel free to leave them down in the comments below. Thanks for watching, and I'll be looking forward to seeing you next time.